Hi, and today I welcome all of you to the first video of our YouTube series Unveiling System Design. Let's today unveil the good and secret behind a great system design. And let's get this video started. So, what will be the agenda for this video? First, we will discuss in detail what is system design all about. Then we will move forward to approaching a system design problem. How should we start to design any system? In the end, we will evaluate how good our system design is. There are certain pointers that should be kept in mind while evaluating whether the design or the system design that we have built is a good one or not. So we will start with what is system design all about. So let's try to define system design. Suppose we work at some tech company and there are certain set of requirements that we have been given. Now as an engineer we want to create a product out of those requirements. That's the definition of system design. In a very easy manner, that's the definition. But since it is quite a generic term, system design, let's try to take it through an example. Suppose I want to design a Twitter. Now, what is the first thing that I will try to come up with? First thing will be the architecture of Twitter. Now, when I say architecture, we will have a database, we will have a cache, we will have a web server, we will have our application server. These things somewhere would be running on the cloud or on premises. Let's see, that's the architecture part. Now we have decided the architecture. Twitter is a way too big system for only one of these things, one database, one web server. So we further break it down into components. Now, second thing that we need to decide are components. Let's say there is a component which is in itself a system, is responsible for handling authentication part. Now within that authentication component, you will have a web server, you will have a database, you will have a cache, you will have a CDN as well. Now we have further break it down into components. Next thing that we need to decide is the modules. What should be the modules? What web server will have on Node.js? What will be running on Java? What will be running on Python? So we break it down into three steps, three requirements: architecture, component, then our modules. Now this is not it. We also make these components in such a manner that when needed, they should be able to communicate with each other. Suppose a web server wants to talk to our database. Now database wants to get some information from some other service, some other microservice running. It should be able to get that. So there must be some communication protocols in our system as well. When we combine all of these three requirements and create a product out of it, that is the system design. I hope with an example it is much clear. Now let's come to the next part. Why it is so popular? Well, every single tech product is a system that has been designed. Companies are building product and need system engineers to build it. That's the reason why it is so popular. Let's see why it has become important for us to learn system design. So what is the first thing is that this is generally what people do at work. If you are in an entry level engineer, you would be working on the module part. You would be writing the code for your web server, your backend, some of the DB, right? Now, if you are a system or a senior engineer, you would be designing caches, you would be designing CDNs, you would be designing strategies to scale your database, you will be doing the fault tolerance and availability thing, right? So it becomes very important for you to understand system design if you are going into the tech industry. Now what happens is that when we grow into our career, these sort of operations or designing part increases. So most of the time you will be designing a system. And believe me, it is one of the most practical thing to do it. And when we build something practical, what happens is that when we use that system, that's a very good feeling out there, right? So I think we are now clear with why it is important to design a system, why it is important to learn system design. Now, what will we actually be doing when we will be designing the systems? First thing, we will be breaking down bigger problems into solvable sub-problems, and then those problems be connected together will give a final solution, will give a final design. We will be deciding on key components and responsibility of each component. Suppose web server should only be responsible for sending a web request or giving some response. Database should be only responsible for the CRUD operations. Scaling or caching should be separately responsible. We always decide on the boundaries of our components. So if one component is taking care of authentication, one component is taking care of the feed, one component is taking care of the notifications, as in I'm taking an example of as in Twitter. One component is taking care of authentication, other one is this. We put the boundaries on each component, right? We do not want the same component to do two tasks that the other component might be doing, right? So we somehow want to achieve mutual exclusive responsibilities for each of our component. And that is not all. We will learn in this series the key challenges of scaling these components, make our architecture fault tolerant and available in case some outage occurs, our DB is down. How will we make our architecture in a manner that our whole system is not impacted and we can recover from the outage? That's about fault tolerance. Thank you, and let's now move to the second part of this video. Now, let's now understand how will we design a good system, how will we approach a design problem, and how will we evaluate whether we have designed a good system or not. So, first point, that is extremely practical subject. System design is a very extremely practical subject, and there has to be some structured way to go to the design solution. You should get overwhelmed, you should not get overwhelmed, you should not digress from your direction. You should be very focused, and there has to be certain steps that you should follow while creating your system design. So let's do one thing. The first step you can understand is take very small steps, take baby steps, no matter what. Let's say we are designing a Twitter. In the earlier video part, we discussed we are designing a Twitter system, and once Twitter comes to mind, it's a way too big system to design it in a one go. So first step that you should do is take very small steps no matter what. Second thing you do is understand the problem statement. Now, understanding problem statement is the most crucial important step while you are designing any system, because if you are not understanding the problem statement, it becomes very easy to digress from your actual problem. Let's say you have to design a server that will handle 100 million requests per month. Now you have designed a system that will handle 1 billion requests. Now what happening here is that is over engineering, right? That is you do not need 1 billion. You should design your system to be optimized only for 100 million requests per month. Now if you design your system that way, if you design your system in such an optimized manner, what happens is that in future, if you need to scale it to 200 million or let's say 500 millions, let's say 1 billion, 2 billion, you do need to tweak certain things, certain changes in your architecture, and you will be good to go to scale that system. So second point that should be kept in mind is understanding the problem statement. Now coming to the third point, break down your system into breakable components. Now what do I mean by breaking down components? Let's say we are designing the Twitter, and to design a Twitter, how can we come up with the first approach? Like, what is the first thing that we can do? We can first either break it down in terms of features, we can then break it down in terms of component, and then we should move on to one component one by one. So what am I trying to explain here is breaking down stuff helps you while you approach any system design problem. But keep this point in mind that when you are designing any system and you are breaking it down into further components, do not just draw the boxes for the sake of it. Only keep the component if you are short about its key responsibilities, how you are going to scale it, where are you going to put it into your whole architecture. Only then put the component into your system design, because just making it for the sake of it, like our system will be very scalable and very fault tolerant, that will digress you from the actual system design. So draw your boxes when you are very clear that yeah, I need this component for this particular feature, I need this component for this particular feature. Now let's try to draw a very basic diagram for Twitter, and that way we can understand how can we further break it down into components. That's a step 2. So for a Twitter we will need, let's say auth, we will need one component handling the authentication, that's a feature. Notifications feature, that we will need for our notifications. We will need a feed, and we can further divide it into more features according to our need. So let's try to draw a simple diagram and try to understand using that part. So suppose this is our user and this is our Twitter. Mind my drawing, Twitter, and let's break it down into further component. Let's say we are designing one component for authentication, one component for feed, that home screen you get while you open the app, and let's draw it this way. One component for authentication, one for feed, and other one for notification. So what happens when we draw things like that is that now when I'm looking into this diagram, it is very clear to me that I'm starting designing the Twitter, and I have breaked features into components that is big enough for it to have a microservices of their own. Authentication will have one service, feed will have one service, notification will be one service. These three will be independent components. Combined together, we will make it a very good system design. That was the step 2. Now what the step 3 should be? Now let's say step 3 should be dissecting each of these components into their subcomponent. Right? Let's say we have this authentication, we have this feed, we have this notification. Now we can do one thing, that we can dissect each of these subcomponents. Let's say we want to further break down what feed will look like, the component feed will look like. Let's try to draw the feed design. Let's say here is our user, and that should be big enough box to design feed. And suppose we will have one web server that will be serving the request to the users. We will have a database that will be holding the information of every user that is logged in on Twitter, and we will have this generator. In a minute I'll explain what generator will does, and we will have one aggregator. This will be taking information from this will be giving data to this, aggregator will be giving data to this, yes, that will be feed system. Now guys, let's see what is happening in this system is this web server. This will take some information from the database and this will serve it to the user. Role of this generator should be very much defined. I earlier told in the video that we should properly specify the key responsibilities of each component. Web server will be responsible for sending a user response that the user has requested to. It will be taking from database, and database will be for the storage part. Generator part will be, what will this generator do? This generator will take the feed from so many other services. It will take some feed from the users liking post. It will take some recommendation videos from the recommendation engine, and it will combine all those into a ready-made feed that should be available to the web server. When a user responds for the feed, web server can fetch it from the database and send that feed. Now what's the use case of this aggregator here? Well, if we say we keep our system like this, if we are not putting the aggregator here, even this system is fine, because we know the key responsibilities of each of the component. We know what the generator is doing, we know what the web server is doing, we know what the database is doing. So if at a moment you are not sure what a particular component is doing, it's better not to draw it. But if I am drawing it, I should be very much aware of the role and responsibility of each of the component. Now what this aggregator would be doing is that, suppose a generator has provided a pre-fetched feed page to our database. Now we want to filter out certain posts. We want to make a very ready-made post for each user, a custom post, and we want to filter out some posts, we want to filter out some of the recommendations. So generator provides a very raw feed, something containing a lot of information. Aggregator will simply reduce all the redundant information and create a very customized feed for every user. And we can further break down aggregator and generator as well. But the whole idea that I want to convey is that in the third step, you dissect each component into further subcomponents, that is feed, and you define the roles and key responsibilities of each of them. Now if you are into like understanding feed generator, like how this generator will be putting, let me draw the diagram for it as well, and we can get a better idea about that. So let's say we have a database here and we have a merger here. This merger is taking some post from post service. It is taking some recommendation from the recommendation service. It is also taking some followers from the follower service. Combining all these, this merger is providing it to the feed database. Now if we combine this whole system and this feed database will be providing the complete raw feed to the web server component. So guys, this is something that feed generator will look like. That is generating your post and giving it to the web server, right? And this feed generator depends on many services. As you can see, post service, recommendation service, follower service. There is a lot of dependency on this feed generator, right? So we have simplified it into 3 steps, and now at the end let's try to understand this part. Now see, we have dissected it into the subcomponent. We have covered our 3 steps. So just remember this, that if you are designing a bigger system like Twitter, like e-commerce, you should follow the top-down approach. You break it down into further components. You understand the problem statement. You break it down into components. You break it down into further components, dissect each component, and you make a system design approach in this manner. But if it is a small system, you go from the bottom-up approach. Like, you know, every system needs a database. Start designing database. You know every system needs a CDN. You know every system needs a load balancer. You know every system needs a cache storage, web server. You start building small things and you move up as your problem statement suggests for smaller systems. Now let's evaluate our system. Very important part. How will we evaluate? We have built a good, robust, scalable system. So first we should know that every system out there is infinitely buildable. You should know when you should stop, right? So here are some pointers that will help you out. First, break system into component, further subcomponents we just discussed. Each component should have a clear set of responsibilities. I have been saying this for the starting of the video because that's very important. We do not want same 2 components performing the same functions, right? Because that's repeatability. And we do not want to repeat functions, right? Like, that's a misuse of resources. So we can see our system, Twitter system feed that we designed, and that way we will know that every component have a particular responsibility. So if we go to this part of feed system, see, database having the storage part, it's storing the feed part. Feed web server, it is serving the feeds to the user. Generator, what is it doing? It is pulling data from multiple services, putting them into DB and giving a prefetched prefetched feed page to the database. Aggregator, simply filtering out all the data, redundant data removed, and combining all those together created a final response feed and provided it to the database for web server so that it becomes ready to consume for the user. Now for each component, the last but the important point, for each component you should follow 4 things, 4 technical details you should follow. First is database and caching. What our database is a very brittle component, right? So you should be having a strategy in case database is down. So our whole system can go down. So you should have a strategy in place for that part. Caching. So suppose there are certain things that user is demanding very rapidly. So instead of getting to the database every time, we should have a cache storage in place that can be used to get the information that is needed very frequently, right? So you should consider database and caching for each component and the subcomponents. Like I told you, we have developed a feed component and then we have segregated it into generator, aggregator. You should think of these 2-3 technical details for each topic, right? Second is scaling and fault tolerance. As I told you, suppose our web server got down, right? So that web server can take down our whole system. So our architecture should be fault tolerant as well. Scaling. Let's say there are 200 million requests coming to our web server, and we know only one web server is not sufficient to serve that many requests. So how should we scale our web servers? Where should we put the load balancer so that the load is directed in a dividable manner, in an equal manner to each of the web servers? Last, communication. How do these components, these parts of our system, they should be communicating to each other, right? Because we need to decide UDP, HTTP protocols and whatnot. Fourth is async processing. What do I mean by async processing is that suppose somebody is going on a Twitter application and it taking 2-3 minutes to load the fetch. So that becomes a very bad experience for the user. So what we do is we delegate it to the server that please pre-fetch the information, and once the user comes we can show him the feed in a very less response time. That's called async processing, that you are delegating some work behind the scenes. It is being going on, but you are not waiting for it. You are just delegating it. Once it is ready, you will show it. That's async processing. So 4 things that are very important: database and caching. Second, scaling and fault tolerance. Third is async processing. And fourth is communication between all of them. I believe now it is very clear that how should you design a system and how should you evaluate whether you have designed a good system or not. So that's all about this video. Stay tuned for more videos like that, and thanks for watching this video.